Just to introduce myself for those of you who don't know me. So that's me. I will today have a weather briefing that I actually prepared yesterday due to some domestic trouble, but I hope it will still be satisfying to you all. But I will not begin with the situation from yesterday. I will begin with the situation that we are following for, I could say, a month now, or at least some weeks, with the floodings all over Europe. And what I wanted to show you in the beginning is how well the floods on Elbe River could be seen in MODIS images. This in the upper panel is MODIS image from NASA Terra satellite observed on 6 June this year. And if you compare it to the lower image, which is observed on the 5th of May, you will see how huge Elbe River was on the 6th of June, and I guess some of the parts still are, and still are flooding. So it is obvious that the size of the floodings was big enough to be seen from the satellite as well. Apart from seeing the river itself in the visible channels, what you could also use while studying or while observing the floodings are the products that give you the possibility to see what is the moisture of the soil, which then can help you in maybe in judging. I'm not really a hydrologist, but I guess those of you who are more familiar with these products would agree that this soil moisture product help you in judging which of the parts are more endangered, considering the fact that soil is already wet and that it cannot take any more water. So this product that you can see here is actually from ESA's Soil Moisture and Ocean Salinity mission, taken on 31st of May 2013, where you can already see how southern parts of Germany were already quite saturated with water. It was also facts with almost all parts of Eastern Germany, which in the end, especially the South Germany, got the most of the floodings. Here also in North Austria, where the problems also occurred later on, it could be seen that there was quite some soil moisture present. Recently, I also started to look at the HydroSAF products, which are, well, not all of them, but some of them becoming operational. And you can also use these products just by logging into HydroSAF web page and giving your details there, just the email address, and you will be given the password. So if you feel like using HydroSAF products for any operational duties, they are available on the regular basis. For example, these products that you can see now is soil moisture from ASCAT instrument. It is actually derived 2 times daily, so you can have images at 14 and at 2 o'clock. And also from this image, which was taken on 8th of June, you can see a large soil moisture content also here in Austria, still in South Germany, in some parts of Poland, Slovak. So still large parts of Europe had large soil moisture, and then you can follow this development in daily images. As I said, 2 times a day product is operationally available. Besides this soil moisture products, this is also one example that was taken just 3 days ago on 10th of June, and you can see the soil moisture on that day. However, it seems that the situation is becoming more and more, let's say, if not stable, but then calmer, because the rain in the central parts of Europe has stopped to fall. And what you see in this image here is actually the situation from yesterday. This was instantaneous rain rate, also a Hydrosaf product, which you can also have at the Hydrosaf webpage operationally. This one was one from 1542 UTC yesterday afternoon, and what you can see from that image is actually that that yesterday the weather was happening in the eastern parts of Europe, more or less around the Black Sea, and some frontal precipitation was present on the most western parts, especially over British Isles and some parts of Scandinavia, due to the cold front that we will just analyze in a few minutes. So actually the rain in Middle Europe, in central parts of Europe, has stopped falling, and this will definitely help with the situation as far as the water is concerned. We are still having big troubles with the Donau River coming south, and we are just expecting today that it should flood the most eastern parts of Croatia. So we are still fighting with it, and I guess our eastern and southern neighbors will still have some problems in the following days. So this is one of the products, Hydrosaf instantaneous rain rate. What you can also look at is our accumulated rain quantities. So this one is, for example, also from yesterday, 15 UTC accumulated precipitation in previous 12 hours, where you can nicely follow the quantities of rainfall. Estimated, of course, based on several instruments. So this is a combined image from several instruments that gives you then the accumulated precipitation over 12 hours. So as we could see from the images yesterday, the rain stopped in the Central Europe, and the weather somehow moved to the eastern parts of Europe, and this is what we are going to look at. So this is the image from yesterday, 6 UTC, and as you can see clearly in this image is that this part of Europe, so I would say southeastern Europe around the Black Sea, so Bulgaria, Romania, and the countries around the Black Sea were more or less prone to what looks from this 6 UTC image as convective development, whereas the most western part of Europe would be somehow affected by this frontal system that was about to enter Europe from the west. If we concentrate on the situation in the sea level pressure, you would see that actually this convective development that could be seen over Eastern Europe is still connected with this low resigning over Black Sea. So this is a low pressure center that is still active over there, whereas the frontal system in the west is actually somehow divided into three parts. There is a front here with occlusion over, I would say, a little over northern part of British Islands. Then there is another big occlusion here south of Greenland, and there is development here in the cold air also connected to the low center just west of Ireland. These three centers actually form quite a large low pressure center over Northern Atlantic, whereas most of parts of Europe, so Central Europe and especially Mediterranean, is under the influence of pressure ridge, so high pressure, which would in following days be causing stable weather. I would like first of all also to show you the 500 hectopascal chart. This thing is loading very slowly on my side. I hope you will see the image soon. In 500 you can also see that in the eastern so southeastern Europe, there is also in the 500 hectopascal pronounced trough in a pressure trough, and the system over the Atlantic clearly has three, I would say three, but let's say two troughs in the 500 hectopascal, which could be clearly seen over one of the British Islands and one west of Ireland. This is what will be analyzed a little bit later. Now I would like to concentrate actually on the on this more eastern part, so on the situation happening around Black Sea, as this situation is very similar to what we are also expecting today. So actually, if you look at some parameters that could somehow give you the indication of convective development, this is what you can expect in the Eastern Europe. So actually, I first looked at Cape, and as you can see, it was quite clear that the highest values of Cape are present here in around Black Sea, I would say over Turkey, and also some maxima were present here over Romania, Bulgaria, and of course here Greece and southern parts of Turkey were also seem to be prone to convective development due to high values of Cape. When you look at, for example, Showalter-Nix, which can also give you the indication of instability, these same areas come forward. So actually, all the regions around Black Sea seem to be very prone to convective development. Whereas if you look at the frontal system approaching from the west, it seems that the model did not give any convective, let's say, potential in this system. So convective development is expected more to the southeastern Europe, whereas this frontal system will probably bring some more stratiform precipitation in the most western parts of Europe. If we go further on, what I wanted to check also was to see whether the satellite information gives the same idea about the situation over Europe as far as convection is concerned. So if you look at the global instability index from MPEF products, you will see that the let's say parts that would be most prone to convection is actually Turkey, which was also somehow indicated by Cape, but also here north of in the northern parts of Black Sea, convection could be expected, and large values of global instability index are found here over Russia. So actually this is something that can be seen, all this region can be seen as the region where convection can be expected. This was the situation yesterday, but we have quite a similar situation today. This shows you the situation at 12 UTC, where you can see that the clouds, the convective clouds, really developed around Black Sea, all around Black Sea. So actually, and also in Russia, up there, you can see that some serious convective development took place later on. So actually, we could say that the forecast based on stability parameters was quite good. And what else? Yesterday's situation was also by the colleagues from ESSL. So this is here the. If you want to look at this, you in the ePort webpage, you can look at Estofx forecast, which then gives you the idea which of the regions of Europe are prone to convective development. And based on this forecast coming yesterday from Estofx colleagues, there was a chance of 5% severe convective development around Black Sea, I would say, so in southeastern Europe. This is then this somehow finishes the idea about this convective development, and I would like to shift more towards the towards west, where there is well-pronounced frontal system, which is located just west of European coast, affecting British Isles and the most parts of Europe. And what is interesting in this situation is that the big low actually consists of three low centers. And I have now a question for you. I would like you to put a star or whatever sign you like, a letter or whatever, in the places where you think you could expect the highest value of isentropic potential vorticity in the middle and let's say in the middle troposphere. So where you think you have maxima of isentropic potential vorticity connected to let's say cyclogenesis process going on. Okay, more. Okay, good. So you've been studying during the weekend, yeah? I will show you. So it was exactly the places that you pointed at, which, if you look at this water vapor image, could be clearly seen by the dark areas in the water vapor image. So actually, these are the regions where isentropic potential vorticity has its maxima, or better to say, where the maximum of potential vorticity somehow moves to lower parts of the troposphere. Now, another question: where do you think you will have maxima of cyclonic vorticity advection? So where do you think that the advection of cyclonic vorticity is the strongest concerning this big system? Okay. Okay, well, you've been really studying during the weekend. Okay, this is now the image that shows you the maxima of cyclonic vorticity advection at 300 hectopascal, also connected with the wind or with the jet streak, with jet stream location. The jet flows, as you can probably judge also from the image, from north to south here and then to eastwards, and the maxima are found actually here in the just a minute, here in the left exit region of this jet streak, and also here, of course, located within this occlusion, and the other one here also connected to the big occlusion in the northern part. What I wanted to analyze today, and it actually struck me as I was looking at the images from yesterday, is this development occurring in the cold air behind the cold front. So actually this here, which is already connected to a small I would say trough or a low center in the surface pressure field. Here you have a more or less cold front like feature. Here there would be a warm front and an occlusion here, which is clearly occluded, connected to this more eastern low center. But this development here actually still does not look as a clear occlusion. It is not connected to the system itself. It looks more like some cold air development at the beginning. But then if you look more closely to some other parameters, then it occurred to me that it could be one conceptual model that I will explain just now. First of all, let me show you the temperature advection connected to this system. As you can see very clearly, this is definitely a cold front, since here you have a big maximum of cold air advection. Here there is some warm advection, and in this region you have a pair of cold and warm advection, which is definitely pointing towards the idea that cyclogenesis or occlusion process is taking place in this region. And from the temperature advection, I would say it's quite a strong process happening here. If you look at some other parameters, which would be let's say which would be key parameters for the conceptual model I'm talking about, then you would expect to have a trough in the upper level, also in surface, but also in 500 hectopascal. So trough connected to this cloud system in the cold air, which you obviously have here. So you have a trough and you have a cloud system here. And in some later moment, this cloud is expected to join the frontal cloud band in a process called instant occlusion. So the parameters here would more or less fit with this conceptual model. Also, if you look at the thermal front parameter for this situation connected to the equivalent thickness chart, I hope you can see this is quite blur in my screen. So thermal front parameter shows you the location of the cold front, whereas equivalent thickness should be as it really is in this situation. It's even more pronounced. The ridge, the equivalent thickness ridge, is even more pronounced in this region. This process is already advanced. I would say instant occlusion process is already advanced in this image. So these are two other parameters that you could look at, and you can also look at temperature advection, as we already saw in the beginning. And what you expect to find is actually a pair of cold advection and warm advection, and similar to that you have it here in this image. So actually I would say that more or less the parameters would fit to the idea of conceptual model of instant occlusion. However, when you look at the further development of this system, it was not quite clear whether it really occluded or not, because it somehow joined the big system over the North Atlantic, and today it just turned into one big occlusion. Also, a key parameter connected to the instant occlusion is PV maximum, which should be found in the cloud head. So in this system of in the cold air, this would be this one, and then in some later stage there are two PV maxima, one here and one here, which would quite well can be correlated with the idea of the conceptual model. So this was the process that could be followed yesterday. What was also interesting is, if my picture loads, this is the image 6 hours later, and you can see that the occlusion process did really take place. So actually this cold air cloudiness joined the cold front, and the wave was a bit stronger here, so the wave development was somehow intensified. But as I said, today all this system joined into one big occlusion system, so actually the process of instant occlusion could not be followed in the next steps. What you can also see nicely to the east is that even stronger development was occurring in the afternoon hours, some serious convection over Greece, Turkey, and also up here in the north over Russia. So the forecast that there could be some serious convective development was obviously quite good. And as you saw in the beginning, you could base that forecast also on some satellite parameters besides the model forecasts. What I wanted to show you now is actually short, let's say, forecast for today and also for the next days. And actually what you can see is that the warm air is more or less flooding Europe from the south, and what we expect in the next days is actually in all southern parts of Europe and also Central Europe some really summer conditions. Still, what should not be neglected is that this low over Black Sea is still residing here, so still convection can be expected in the southeastern part of Europe, whereas this frontal system that was obviously that was here in the west is moving towards northeast and will not affect Western Europe, but could only affect at this point Scandinavia and the most western parts. So probably Denmark and Netherlands would have some precipitation connected to this situation, and this is what you also can see from forecast accumulated precipitation, that only the most western parts of Europe will be affected, but some serious precipitation can be expected in the southeastern parts of Europe connected to this convective development. Now I'm moving to today's situation. So today in the morning, this was 0 UTC image. As you can see clearly that as it was forecast by the model, today you can see that cold front has moved towards West Europe. This low, as I mentioned, really is now one big low system. You cannot see these three centers any longer, or at least not that prominent as it was yesterday. Obviously, some precipitation is awaiting the most western parts of Europe, especially southern parts of Scandinavia and also Denmark, Netherlands, and probably also Western Germany. But what I wanted to show you is actually something else. I was also looking at parameters connected to convective development. As you can see, at 0 UTC, atmosphere, if you judge by the satellite data, is quite stable. So actually most parts of Europe don't have a large instability except for the southeastern part. So again, parts over Black Sea, which could still today be quite prone to convective development. But this is not what I wanted to analyze from today's images. I was actually thinking of concentrating on this area here. This frontal system seems to be quite intense approaching Spain. It is a question if it will move over Spain or more to the north, but actually this enhancement on the frontal system is quite clear, so the clouds are quite dense. What actually happened at this frontal system can be seen in the image. Hopefully it loads. If you look at the situation in the wind field, so the jet, you will see that we have two branches of the jet stream. One here from northwest, which is connected to the warm front, obviously located somewhere here over Western Atlantic. So this is the warm front cloudiness and the jet connected to this front, and also here this jet behind this cold front cloud band, which is moving northwest. What happened? I will now clear up this thing so that you can see what happened. What happened here? I guess you have the idea what that could be. Could anybody write down, Andreas, don't cheat, write down the name of the conceptual model, which could be seen here in the let's say southwestern part of this cold front? You have letters up there, so write down the name. Or in the text box. No? So you were studying only convection. Okay. This, if you look at the, so as I said, jet coming from here, and here is the frontal cloud band. So what you can see on the, let's say, left of the jet exit, you can see frontal intensification caused by jet. So actually FE by jet would be the short name of this conceptual model. And if you look at other parameters, you will see that that is clearly the case. Of course, in the left exit region of this jet, you find quite pronounced cyclonic vorticity advection maximum, which is actually causing the rising motion in this area, which can be nicely seen if you look at the cross section, which I picked, but I did not put it here. Sorry. Yes, I put it here. So this is rising motion. If we go back to the image, concentrate on the location of the cross section. So the cross section actually starts here in the region of this cloud development in the cold air, and moves through the cold front and then towards warm air, and somewhere in the first third of the cross section, the maximum is of the cyclonic vorticity advection is found. And of course, if you look at the cross section, then you will see that the cold front that we were looking at is this one here. So this is quite well pronounced cold front. Maxima of upward motion, so motion that can cause cloud development, is found here behind this cold front, but this is actually in the very beginning of the cross section, and this is connected to this development in the cold air. But also along this frontal cloud band, there is quite strong upward motion. So actually, as you see, omega equation in business, the rising of vorticity advection with height causes here quite strong vertical motion, and thus this development of cloud intensification on the cold front occurred due to this due to the effect of the jet crossing the cold front. So this is it. I'm sorry, I had another slide here, but it somehow got lost, so I don't have it anymore. If you have any questions, could you, you thought it was an upper wave. Well, maybe it is an upper wave, but I think it looks quite nice. If you combine all the parameters, it looks like FE by jet to me. Maybe it is also an upper wave. Andreas, would you like to comment? Okay.
Yes.
Yeah.
I think you're also right. I mean, it looks like an upper wave, but from the jet, it's if you take the eastern jet, it's in the entrance region of the jet, and that's where I expect the upper wave. So you were looking on the western jet, and then it's in the left exit region. So I think you can put both conceptual models. We are both right, I think.
Yes, I guess, Andres, you're right that both conceptual models could be in place. However, this FE by jet was the first thing. FE by jet was the first thing that came to my mind. What do you think about the idea of yesterday's instant occlusion?
Yes, I think this is the same conceptual model I would have put there. In fact, the only thing I would comment on that is that the warm air and cold air advection you pointed out were strong, but not very strong. So for a rapid cyclogenesis, I would expect a stronger dipole of these temperature advections. So I was not wondering that nothing really bad things happened. So it was developing, but just in a normal way.
Mm-hmm. Yeah, that's what I also thought, is that actually this cold advection was not strong enough to make it real occlusion in the end. And then, as you see today it really joined this big system and somehow disappeared, so there is no maxima any longer. Okay, if not, then we are done for today. Thank you very much for listening, and Vesa still has an announcement to make, so please, Vesa.
Thank you, Natasha. Hello, everybody. Just to remind you that the next session will be on July 19. It's July 11 at 09 UTC, and it will be done by me. So I just opened this page for you. You can already now, if you like, you can just register for the next session by filling in the fields. Or you can go to the EUMeTrain page and find the same link and same registration there. That's all from me.
Okay, thank you, and bye-bye, everyone.